Okay, so the given question is a sample of milk splits after 60 minutes at 300 K and after 40 minutes at 400 K when the population of Lactobacillus acidophilus in it doubles. The activation energy is, so at t is equal to 0 nothing happens. At t is equal to 60 the milk splits at 300 K. Now let us assume that A amount of the milk splits. Alright. Now after 40 minutes the population of Lactobacillus acidophilus in it doubles as has been given here, right? Now we've been asked to find the activation energy in this process. We know that the equation of RTS rate constant is as given here, where K is the rate constant, A is the Arrhenius constant, R is the gas constant and T is temperature. Now when we try to take the integration for this is what we get. Now we also know that rate constant is inversely proportional to time, not temperature, sorry, this is time. So this is the equation that we get. Now let's try to substitute the terms. Ln is equal to T1 by T2. So sorry, T2 by T1, T2 by T1, right? So we put 40 and 60 here and 8.3 for the rate constant, sorry, for the gas constant, which has already been given to us, and we also substitute the temperatures. Now let's substitute the value of ln 2 by 3 here, which has already been given to us. It's minus 0.4 and this 8.3 comes up here, and after completing the rest of the calculation we get activation energy as 3984 joule per mole per Kelvin, but we've been asked in kilojoule per mole, right? So divided by 1000 and the final answer is 3.98 kilojoule per mole per Kelvin. So your answer is 3.98.